we are going to specifically be focusing on quadrilaterals. So as we've already learned, that is when you have a four-sided figure. But there are special types of quadrilaterals. And we're going to start off with a parallelogram. So first of all, the definition of a parallelogram. Now, parallelogram is a pretty lengthy word. That's why there's a symbol for it. So anytime that you want to use that symbol, that is fine. The definition of a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. Remember, we have that symbol. So by definition of a parallelogram, that means that this piece is parallel to that one. And I'm going to go and put some letters in here. That means that AB is parallel to CD. And it means that AD is parallel to BC. Okay, so that is what you get from the definition. There are other properties that happen because of all these parallel lines. And the first property that's a 1, is that both pairs of opposite sides are congruent. So not only do we have the parallels, but now we also know that in our parallelogram, you know that those two pieces are going to be congruent, and those two pieces are going to be congruent. So if we have E, F, G, and H, I know that EF is going to be congruent to GH, and that EH is going to be congruent to FG. Another property would be that both pairs of opposite angles are congruent. So again, if we have a parallelogram, go back to R, S, T, and U. So based off of that property, I know that R is congruent to T, angle R is congruent to angle T, and I know that angle U is congruent to angle S. Another property would be that consecutive angles are supplementary. Okay, so consecutive angles meaning in a row, and supplementary means that we have two angles equal to 180. Okay, so if I look at this, and I have M, N, O, and P, I know that the measure of angle M plus the measure of angle N has to equal 180 degrees. So these two have to equal 180 degrees. I know that the measure of angle N plus the measure of angle O has to equal 180 degrees. And the measure of angle O plus the measure of angle P equals 180 degrees. And finally, the measure of angle P plus the measure of angle M would equal 180 degrees. And that is because if we go back to this idea of parallel lines, I'm going to zoom this down here. If I have parallel lines, then I have, if you remember, that one and that one are called same side interior or consecutive interior. And we know that they are supplementary. But don't forget you have these parallel lines as well. And based off of another one, I have this parallel line and this one. So now A and B are also a pair of same side interior or consecutive interior. Then I can go back and look at angles B and C as well. And then this brings full circle the fact that both pairs of opposite angles have to be congruent. There's one other property, and this is the one that's probably missed the most. So this is going to be property number 4. And that is that diagonals bisect each other. But like a little note here, they do not bisect the angles. We do not have that. They do not bisect the angles. So if I have a parallelogram, we'll do G, H, J, and K. G, J would be one diagonal, and H, K would be another diagonal. From this property, if diagonals bisect each other, that means, and I'm going to put this as L as the point of intersection. That means that GL is congruent to LJ, and that means that KL is congruent to LH. Notice I'm using different number tick marks so that you are not thinking that they are all congruent. Okay, so we're going to do some really quick examples applying these properties. You have to know these properties so that you can actually set up the equations to solve for the missing pieces. Okay? So, if I have example 1, and I'm telling you that it is a parallelogram, okay, so you're given that it's a parallelogram. I know then that these are opposite sides and they are congruent. If they're congruent, they're equal. So then I can set them equal to each other. So that is going to be how we set up our equations by using those properties. So x equals 0, and so if I plug this back in, I have both sides equal 15, so that checks. Example 2, again I'm given a parallelogram. So we have parallelogram DEFG. And remember we talked about this before, that if you have the 4 letters, it has to be consecutive. You can't just bounce all over the place when you're labeling them. So if I have this parallelogram of D, E, F, and G, and I have angle E is 3x plus 11, and angle G is 5x minus 9. I know that these are opposite angles, and in a parallelogram, opposite angles are congruent. So then I can set them equal to each other. Solving, subtracting 3x, I get 2x. Adding 9, I get 20. So then x equals 10. Now be careful because on some occasions it might not just ask for x. It's going to ask for what is the measure of angle E. So you have to remember to plug it back in. 3 times 10 gives me 30. Plus the 11 gives me a measurement of 41. So by having one of the measurements, it's going to give you enough information to find the others. And last example that we're going to do is if you have parallelogram, let's see, which one haven't I done? Parallelogram PQRS. P, Q, R, and S. And we have two diagonals drawn, and they intersect at point T. If I know that RT equals 19.8, so RT equals 19.8, find the measure of PT and find the measure of RP. Ooh, I'm way off my paper there. There we go. So if this is 19.8, again, I'm going to use my properties. I know that these are congruent because diagonals bisect each other. So if this is 19.8, then this also has to be 19.8. So PT is also 19.8. RP is the length of all of it. So using my segment addition, I have 19.8 plus 19.8 gives me 39.6. So again, you have to know the properties in order to be able to set up the equations and to solve and to answer what is being asked.